Number 8, propine gas, okay, which actually is an organic chemistry mechanic here. They're actually telling you the carbon to carbon bond status. But this gas can be used as a fuel. The combustion reaction of propine can be represented by the following equation. Now, notice, we got it all balanced for you. Again, if you don't believe me, check it yourself. There's no harm in it, right? Make sure that you have good information, a correctly balanced chemical equation as you're going forward to do your quiz and test questions. A asks us to write all possible mole ratios in this system. Holy cow. There's going to be a lot, just FYI. But I like to do just kind of like the drag it out method. I think in math class I call it the FOIL method, first, outer, inner, last. Learned it when we were going over binomials, but what I would do is I would take my pencil and I would write connecting arrows. Right? And that would make sure that I hit every relationship. Then I would go here. And then lastly, now if I'm, without even writing down what the ratios are, I notice that I've written 6 lines here. 6 connecting, well, I guess not lines, but arches, right? I've connected 6 different relationships. There are 12 lines. Why? Because each mole ratio can generate 2 conversion factors. And that's what we're trying to get out here. So we're going to have to actually write everything twice. So first, 1 mole of C3H4 to 4 moles of O2. And you know what? I'm just going to write the reciprocal right now. 4 moles of O2 to 1 mole of C3H4. Next up, I'm going to go that C3H4 to the CO2. 1 mole C3H4 to 3 moles of CO2. And I'll write the reciprocal right now. 3 moles of CO2 to 1 mole of C3H4. Next relationship is the hydrocarbon to the water. So 1 mole C3H4 to 2 moles of water. We'll go ahead and write the reciprocal right now. 2 moles H2O to 1 mole C3H4. Alright, so we've covered this hydrocarbon's 3 relationships to the other 3 substances. And so now we're going to go down here and start with O2 and go to CO2. So it's a relationship of 4 moles of O2 to 3 moles of CO2. Go ahead and write the reciprocal. 3 moles of CO2 to 4 moles of O2. Next relationship is the O2 to the water. So 4 moles of O2 to 2 moles of water. And the reciprocal would be 2 moles of water to 4 moles of O2. That's the last of those relationships. And the last one we have is the CO2 to the water. That would be a 3 moles of CO2 to 2 moles of water. And a reciprocal to finish it out. 2 moles of water to 3 moles of CO2. Last thing I'll say on this before I move on, notice that regardless of how you draw these mole ratios, how you draw these as conversion factors, whether one substance is on the numerator and the other one's on the denominator, or you flip them, the number that's associated with that species, for example, the CO2, wherever I've written CO2 in every example, it's always 3 moles of CO2. In every single example where I've written a CO2, it's always 3 moles, because the coefficient is 3. Every time I wrote O2, each and every time I wrote O2, it was always 4 moles of O2 because the coefficient of the balanced chemical equation for oxygen is 4. Now let's use some of this information to get a little bit abstract for B, finishing up the worksheet. Suppose that X moles, meaning an unknown, it's a variable, we don't know what it is. Suppose that X moles of water form in the above reaction. The other 3 mole quantities, and just by the way, I'm not saying this in order, are 2x, meaning 2 times whatever this number is, 1.5x, and 0.5x. Match these quantities to their respective components in the equation above, this equation that we've just been looking at. So, water, let's just say there's X amount. We need to use the mole ratios to the CO2, to the O2, and the hydrocarbon to identify which species, right, because there are 3 other species, which is the 2x, which is the 1.5x, and which is the 0.5x. So the ratio of water to everything else is always going to be 2 to something. Okay, for example, there's 2 moles of water to 1 mole of C3H4. This is a 2-to-1 ratio. That means, compared to water, however much water is present, there's going to be half as much of the hydrocarbon. That's the 0.5. Right? That's the 0.5. So the C3H4 is the 0.5x. Fair enough? Now, when we look at water to say the O2 relationship, it's a 2 to 4. Okay, let's see, where's that? Where? Okay, 2 to 4, 2 to 4. So however much O2 is being used, half of that amount of water is created. I should say that the opposite way, it might be a little bit more clear. For however much water is generated, you needed twice as much water to go into that. You needed twice as much water to go in, or twice as much O2 to go into that, sorry. So that means that the O2 is 2x. Now, we can already figure out that that means that CO2 is the 1.5x, but let's demonstrate that using the same type of logic. Again, the coefficient in front of H2O is 2. The coefficient in front of CO2 is 3. That's a 2 to 3 ratio. So however much water is produced, 1.5 times, right? It's a 3 to 2 ratio. 3 divided by 2 is 1.5. It's a 3 to 2 ratio. 1.5 times as much carbon dioxide will be produced for however much water is produced. Okay, so CO2 is 1.5.